So we are going to begin our skeletal unit, which is basically all of the bones of the body. Starting with, what are the parts of the skeleton? So we divide the skeleton up into two sections. The axial skeleton, which is the reason we use axial is because it runs along the axis of the body. You could think of that as the midline or the median. And that is the core part of the body. That's the skeleton, the rib cage, and the pelvis. So that center core of the body. The appendicular skeleton is just what it's named for. It's the appendages. These are your arms and legs. So let's talk about functions. The biggest one is support. It is your framework that all of your organs attach to. It is the rigid underpinnings of all of your organs. It's protective. So bone is very hard, and because of that, it provides a great casing for all of your soft body organs. Things like the skull, the vertebrae, and the ribs, these act as protectors. Movement. In order for our muscles to function, they act as a lever, and they need something to pull against in order to provide movement. Bones are that rigid piece that allows muscles to contract against and create leverage and movement. We have storage. So we don't often think about bones being a place where we store fats and things, but bone marrow is a huge source of fat, and it also is a great place for storing some minerals that we need, things like calcium or phosphorus. It is all throughout the body, so you have access to those minerals anywhere throughout the body that might need them. It is also the site of red blood cell production. In many bones, we have red bone marrow, which produces blood cells. This would be red blood cells, but it also, if you remember from our immunity unit, it also is the site of white blood cell production. Things like B cells and T cells all develop in the bone marrow. There are two types of tissues in bone. We see compact bone, which is dense and has a smooth appearance, whereas spongy bone is these needle-like crisscrosses of bone tissue, and these kind of fill in the gap. Spongy bone is incredibly important because spongy bone is what reduces the weight of our skeleton. Our skeleton is already very heavy, and if our entire skeleton was made of compact bone, it would be nearly impossible to move it around. It is what makes us able to move is the fact that our bone does have this rather porous texture of spongy bone. So here are the two different bone tissue types. So here you can see the compact bone on the outer edge, and then here you can see that spongy bone, and it looks like a kitchen dish sponge. It has all of these spaces and gaps, and you can see it's got all of these places where we can have blood vessels running in, and we can have red bone marrow where we're making red blood cells. So you can start to see how much space a bone might have, even though we think of them as solid. So how do we classify our bones? We classify them by shape. And we have 4 different categories, and we're going to talk about each of these in depth in just a second. Starting with long bones. These are bones that are longer than they are wide. That's how we describe them. So these are the bones of the extremities or the appendages. except for the bones at the ankle and at the wrist. And we'll come back to those in a second. So these are going to be your humerus, your radius, your ulna, your femur, tibia, fibula, your metatarsals, and metacarpals. Then we have short bones. These are bones that are basically equal in length to their width. So these are cube-shaped bones. These are the bones of the ankle and wrist. This also sometimes includes the sesamoid bones. These are bones that are found exclusively in a tendon. They don't actually like align with any others. The patella is the best example of a sesamoid bone. Sometimes you will see sesamoid bones set off in their own category. Sometimes you will see them lumped in here with short bones. Just be aware of the fact that sesamoid bones often have this cube shape. They're often as short, they are as long as they are wide. Then we have flat bones. These are thin and they are usually curved, and they don't have a lot of depth to them, so we call them flat. And these are generally, what you're going to see is that the spongy bone goes the entire length and then is sandwiched between compact bone that covers the outside. So the most common examples are going to be the ribs. Those are those long, flat bones that come in around the chest. And then you're also going to see like the cranial bones, what we call the skull. Those are cranial bones. And then you have the sternum, or like what you might refer to as like your breastbone. And those are all considered flat bones. Irregular bones are bones that don't fit into any of the other categories. This is just kind of a catch-all category. And these are going to be your vertebrae and your coxal bones. So that's going to be your spine. And then the coxal bones are your tailbone. And so here's what those look like. So you can see we have the flat bone. And remember, that could also include the sternum. You have the irregular bones, which is going to include your spine and coxal bones. Then you have short bones. These are what make up the wrist and ankles. And then you have the long bones, like the humerus or the other major bones of the appendages. So let's talk a little bit about how a bone is structured. So the diaphysis is the shaft of the bone, or the main portion of a long bone specifically. The epiphysis is the ends of that bone. We talk about distal and proximal ends because remember, distal means further from the core of the body. Proximal is closer to the central portion of the body. And on those distal and proximal ends, we'll see articular cartilage. This is a thin layer of cartilage covering those epiphysis so that the bones don't rub against each other. Bone, while it's very strong, it can be very brittle, so it can chip. So we want a smoother surface that allows for cleaner movement in the joint, so that as the joint is moving, it is a smooth, clean movement. And that's what the articular cartilage is achieving. We also have the periosteum. This is the hard outer coating of the bone. And then we have the medullary cavity. This is the space where we have a gap in the shaft, and this is where the fatty yellow bone marrow is located. If you've ever seen a dog chewing on a bone, the fatty yellow bone marrow is what they're trying to get. And if you've ever made like bone stock, if you've ever like boiled a carcass to get like bone broth, like chicken broth that you buy at the store, this is how they make that. They boil the bones. And what they're doing is they're releasing that fatty bone marrow into the water in order to flavor it. So here's what that looks like. So you can see the epiphysis at either end, and then the diaphysis in the middle. And as we kind of break that down, you can see we have the fatty yellow bone marrow in the middle, in the medullary cavity. That's this gap right here. And then you can see the spongy bone as well. And it allows for blood vessels to run through it. And you can see the difference here with compact bone as well. And then you can see the peristeum there. That's that coating that makes the bone look smooth. And then if we move into a microscopic view, you can also see things like the osteocytes. The osteocytes are the actual cells that are building the bone tissue. So kind of similar in like shape to what we remember about the melanocytes. Remember they had those like long tendril-like extensions in order to help facilitate moving the melanin into the surrounding cells. The same kind of principle is used here with osteocytes. These long tendril-like extensions allow it to move the bone tissue that it's creating out around itself. So you can kind of see what that looks like there. So this is going to end our lecture that introduces the skeletal system. And then we're going to move on to our next section.